Good afternoon. I've got 2 o'clock, so we're going to start our webinar. This is Victoria Beal at the Ohio LTAP Center, and I'm very pleased to have Ron Garczewski from the Ohio FHWA Division Office, who will be our presenter for today's webinar on Type A guardrails. Before we get started, we have a few housekeeping items, which also includes a poll that we've had up and running since before the webinar started. We'd like to ask, as you're joining the webinar here, or if you've been on the line for a few minutes, if you would please go ahead, complete the poll, because we'd like to know who our audience is comprised of, kind of get a snapshot of who is participating today. And I also wanted to mention that everyone has joined in listen-only mode. We do have the ability for you to ask questions, and we ask that you do it through the chat pod that's available on the software that we're using for the webinar. The chat pod, if you don't see it already on the bottom left-hand corner of your screen, can be made visible by looking for the circle with the thought bubble in it and clicking on that. And then it should be a chat pod that says conversation at the top that'll open up for you. Please pose questions throughout the webinar. We will read those off to Ron so he can provide responses, or if he doesn't have an immediate answer for you, we will find the answer and get it out to you after the webinar is completed. The other thing I want to mention is we are attempting to record the webinar. If we are successful, a link will be sent out afterwards to everyone who registered, but in case we're not successful, it's a good thing you're on the webinar because you're going to get to participate in real time. So with that, I'm just going to give you a few seconds more to finish voting, and then I'll be taking this poll down and we'll turn things over to Ron. And I do want to mention that Ron's responsibilities as our safety engineer here in Ohio for the Federal Highway Division Office do not normally include doing webinars. So I want to thank him profusely for putting all of this together and doing this for us. I know it's definitely above and beyond in his role as our safety engineer, and I want to thank you very much, Ron, for being a part of this tech transfer activity. So
well, thank you, Victoria. I'm glad to do it. So.
I'm going to go ahead and take our poll down, and then I'll turn things over to you so you can go ahead and get things going.
Okay.
All right.
And you want me to share my screen, correct?
Please. Here we go. We see it loading up. All right, we see it. Thanks, Ron.
Great. Thank you, Victoria, and thank you all for participating in today's webinar. Looks like we have a pretty good mix of agencies represented, covering both ODOT as well as counties and a couple cities and some private sector participation as well. So we really do appreciate you taking the time today to be on this webinar with us. I'm going to start by going over some basic roadway departure safety information, including a few crash statistics, as well as the strategies that are recommended to reduce the number of roadway departure fatalities and injuries on our roadways. Then I'm going to highlight the key principles of roadside hardware. What is necessary for these devices to perform as we want them to perform? Hopefully these two items then will help set the context for why we at Federal Highway are interested in guardrail end terminals. And then finally, the majority of the webinar will be spent covering the turn-down end terminal, also known as the Type A end terminal. And I've come to find that Type A is not really a universal designation, but at least in Ohio it's called the Type A end terminal. So I'll start with showing some data nationally. The pie chart on the left of this slide shows the percentage of traffic fatalities in the U.S. By focus area. And here at Federal Highway, we have three main focus areas in highway safety: roadway departure, intersections, and pedestrians and bicyclists. Doesn't mean we're not concerned with other crash types, such as rear-end crashes that might occur away from an intersection. It's just that when you add up these three areas, they make up about 90% of all our fatalities on our nation's roadways. And as you can see, roadway departures represent the largest percentage at 47%. And when we say roadway departure, we're really talking about lane departure, because a crash is considered a roadway departure whether you leave your travel lane to the left or to the right. You can also see in that purple slice that 11% of the fatalities involve multiple focus areas. And when we break those down in the pie chart on the right, you see that another 5% or so involve a roadway departure and either an intersection or a pedestrian or bicyclist. Example would be a motorist who may drift out of their lane on the right side, striking a bicyclist on the shoulder. So we really have 52%, or over half of all our fatalities, are roadway departure related, which is why this remains a top focus area at our agency and why it should be a top priority for all of us as we work to advance our highway projects and programs. Now taking a closer look at roadway departure fatalities, this pie chart shows the most harmful event that occurred during all of the roadway departure fatal crashes in a given year. The numbers shown are the average annual numbers from 2015 to 2017, which is the most recent 3-year period for which we have data at the national level. As you can see, leading the way are head-on crashes, when someone crosses over the left side and strikes a vehicle going the other direction. Over 5,000 people are killed each year in the U.S. in head-on crashes, which is clearly a problem. Rollover crashes and tree fatalities are the next highest. What you can also see on this chart with the orange slice that I've highlighted is that on average 955 people were killed each of the last 3 years in the U.S. when they went off the roadway and struck a roadside barrier, with that barrier being noted as the most harmful event of that crash. Now maybe the barrier performed as we expected it to, and maybe there were other circumstances that contributed to the fatality, such as excessive speed or maybe a impact angle that the device wasn't designed for. But regardless, we place these devices out there to help protect motorists and try to lessen the severity of a roadway departure crash. So their design and performance are of great concern to us. So what can we do to reduce these roadway departure fatalities and injuries on our roadways? Well, there are quite a few strategies that we can employ, and we group them into 3 main areas or objectives. First, what can we do to keep vehicles on the road? Next, if they've left the roadway, what can we do to reduce the potential that they will get into a crash? And finally, if they've left the roadway and it looks like they can't avoid a crash, what can we do to minimize the severity of that eventual crash, which is where guardrail and end terminals come into play. First, what can we do to help keep our vehicles on the roadway? Well, we have several strategies, and these are the ones that Federal Highway is currently promoting and highlighting. First, we can make sure our pavement has enough friction to help motorists navigate the curves and hills that are out on our roadways. In certain areas, we probably want to make sure we have the best friction possible with something called high friction surface treatment. That treatment uses an aggregate that resists polishing, so it maintains high friction levels over a pretty good period of time. Yes, it comes with a higher cost, so the intent is to use it at the higher risk locations. Next, we have rumble strips and rumble stripes, which we probably all know. They provide a warning that you can hear and feel, letting you know that you've left your travel lane. Could be centerline rumble strips, edgeline rumble strips, or shoulder rumble strips. Newer cars that have the lane departure warning feature also give you that audible warning. We can also help motorists stay on the road by better delineating our curves with enhanced signage and pavement markings, and also providing lighting at spot locations to improve nighttime visibility. But we know those strategies may not be enough, so what can we do to help to reduce the potential for a crash when a motorist does leave the roadway? So here we're looking at strategies such as the safety edge or clear zone improvements. Hopefully you've heard about safety edge by now, but if not, it's basically shaping the edge of the asphalt pavement to a 30-degree angle as opposed to just a straight vertical edge. The idea is that when the stone or earth shoulder material that gets backed up to the pavement eventually wears away, what will remain is this edge that motorists can better recover and get back on the roadway. Without it, the motorist will go over the straight drop-off and often overcorrect, maybe lose control on either the side slope or come back across the pavement and then go into oncoming traffic. Also, widening the clear zone and flattening the side slopes should also be used to help people recover. While we recognize that this isn't feasible everywhere, we really ask agencies to consider making these improvements at kind of high-risk locations, curves that you know that either have a crash history or have the potential for run-off-the-road crashes. After we tried keeping vehicles on the roadway and reducing their potential for a crash, we come to the point where we accept that they're going to get into a roadway departure crash. At that point, we then say, what can we do to minimize the severity of that crash? Well, we need to take a look at the hazards we have on our roadside. What are people really going to run into? And then follow this preferred order of treatment. Our hazards could be a steep slope on a high embankment, could be a body of water, could be an overhead sign support, or just large trees. Just like we wouldn't automatically construct a grade separated interchange if you're having crashes at an intersection, we really also shouldn't just be throwing out guardrail if you're having roadway departure crashes. First, can we remove the hazard? Can we just simply take it out of the location that it's in? If not, can we redesign it? Maybe if we extend the culvert a little and do some regrading, we might not even need guardrail. Can we relocate the hazard, such as removing trees that are close to the roadway and maybe planting them at or outside the right-of-way? Yes, people don't like trees to be removed, but if you can explain the safety issue and then move or plant them further back, you may be able to overcome their opposition. Can we make the hazard breakaway, such as what we do with large ground-mounted signs on the freeways? We don't place a barrier in front of them because their supports are breakaway. If we can't do those, then yes, we should shield the hazard with a crash-worthy device, with either a barrier, an end terminal, or a crash cushion. And finally, if we can't even get a barrier in there, we should at least delineate the hazard so motorists are aware that this hazard exists on the roadside. So with these beginning slides, I hope you have a better sense of the context for why roadway departure safety is a top priority at Federal Highway and how guardrail and their end terminals fit into that context. We place guardrail and end terminals out there to shield motorists from hazards. If at all possible, we don't want them to become the hazard that causes the most harm during a crash, which, as you saw a little bit earlier, can happen. And that is the overarching principle for installing roadside barriers for guardrail and their end terminals. The barrier out there must be less severe than the hazard. Otherwise, we would rather people just run into the hazard. So the barrier must be less severe. Again, these barriers are hazards themselves. They have steel and wood components that are strong. They will damage vehicles, and they will impart energy to the occupants inside them. So we must do everything we can to help make sure that striking the guardrail is less severe than striking the hazard that it's protecting. And how we do this is by providing hardware that's crash-worthy. Crash-worthy means that the hardware is compliant with the testing criteria of the current national standard, which is currently either MASH or NCHRP 350, depending on the device. MASH stands for the Manual for Assessing Safety Hardware, and NCHRP stands for the National Cooperative Highway Research Program. These documents, what they do is they define the criteria that are used to test barriers, as well as the criteria for what needs to happen to the test vehicle for the barrier to be considered crashworthy, which I will better define a little bit in the next slide. The next key barrier principle is that Federal Highway Administration has a policy that requires that hardware installed on the National Highway System, or the NHS, be crashworthy, meaning it is in compliance with these testing criteria. If you're not sure where the NHS routes are, you can find them a couple different ways. You can just go search FHWA NHS, and we have an interactive map of the NHS for the whole country that you can zoom in and see where the routes are. Or I know if you go to ODOT's TIMS webpage, there is an NHS layer there that you can select and see where the routes are in Ohio as well. This policy for crashworthiness on the NHS is regardless of funding source. So if you have a local NHS route and you want to install guardrail or replace guardrail that's been damaged beyond repair with local funds, it still needs to be crashworthy. All hardware on the NHS needs to be crashworthy, whether the Federal Highway is paying for it or a local agency is paying for it. In general, for a barrier to be considered crashworthy, the following criteria must be achieved during the crash test. So the vehicle must be directed or come to a controlled stop and remain upright. It can't roll over at all. There must be no penetration or significant deformation of the passenger compartment. In other words, nothing entering the compartment where the driver or the passengers are. There also must be acceptable occupant velocities and accelerations. And it's really deceleration forces, because we're obviously crashing them in to something and it's stopping, but they are called ride-down accelerations. That's why it's listed as acceleration. And finally, the vehicle must exhibit an acceptable trajectory after impact. There's a certain area that it needs to go through after it strikes the barrier. We test guardrail and the end terminals under what we call the worst practical condition. That is, we use a car and a pickup truck traveling at 62 miles an hour at several angles that range from 0 degrees to 25 degrees. We don't test every vehicle at every speed and at every angle, but these tests will cover the vast majority of crashes that occur out on our roadways. Yes, a vehicle traveling 80 miles an hour loses control, starts spinning, and strikes the end terminal with its driver's side door is probably not going to exhibit the crashworthy results that we're looking for. But again, the concept here is that we're trying to account for the worst practical condition, and that's why we use the car and pickup at those speeds and angles. Okay, with that background, I'd like to move into the specifics of the turn-down guardrail end terminal. And in case you're not familiar with it, this is a photo of one. Again, in Ohio, it's called the Type A end terminal. First, I'd like to talk about the history of this device and then go into where we are at with it today. So prior to the 1960s, the ends of guardrail runs were basically unprotected. They were just blunt ends out on the side of the roadway. As you might expect, this led to some tragic and spectacular crashes, spectacular in a bad way. The obvious result is that the guardrail would spear directly into the passenger compartment, seriously injuring or killing the driver and possibly the passengers as well. So in the early 1960s, they came up with the idea to take the first section of the guardrail run, twist it, and turn it down 90 degrees and anchor it at the ground level. It would still provide the tension that would be needed for the guardrail to function, but it would eliminate the spearing problem, which it did do. It basically solved the spearing problem. However, it wasn't long after that, in the late 1960s, that it became apparent that the turn-down section acted like a ramp, raising concerns of vehicles vaulting and rolling over. In the 1970s, these turndowns were considered good practice and were widely implemented. However, concerns continued to grow with the ramping and vaulting. So in the late 1970s, engineers came up with some updated designs to try and eliminate the vaulting issue. There were a variety of these updated designs. Then some of them flared the end terminal. Another design used clips over the rail instead of bolts to allow for a quick release. So the end terminal, the theory was it would lay down as the vehicle went over it, and the downstream guardrail would absorb the energy and stop the vehicle. This was the idea to solve that vaulting issue, but they still had performance issues with the system, not performing as they intended. Turndowns continued to be used throughout the 1980s with minimal changes, maybe some design tweaks here and there. And then we come to 1990, which is the beginning of like what I call the era of FHWA guidance memos related to the turndowns. I'm going to go through each of these 4 memos over the next series of slides a little bit more in detail. Both on this slide and the following slides, the text in blue, these are hyperlinks that take you directly to the memo itself. So for example, if I click on one here, you should see that I'm opening it up. The very first memo in 1990, you'll see has a bunch of watermarks that say superseded, meaning our guidance is really in subsequent memos. However, there is actually good background information if you read this memo. So if you want to read the memos, you can find them via these links. As we talk about these, just keep in mind that the guidance is mainly for the approach ends of the guardrail runs as you're approaching. It doesn't technically apply to the trailing ends unless there is the likelihood that of an opposite direction impact, where a vehicle could cross over and maybe hit the end from the opposite way. So the first memo that we issued was back in June of 1990, which is actually 29 years ago now. The memo was prompted by increasing concerns out in the field coming from both state DOTs and our Federal Highway Division offices. And the problem continued to be the vaulting and rollover of vehicles that were hitting these. The memo talks about these problems occurring with all variations of the turn-down designs, including the flared and quick release mechanisms. It also states that these end terminals are not to be used on high-speed, high-volume roadways. So that was sort of the first official position we took on these devices. The memo states that they, at the time, may be used on low-speed or low-volume roadways based on risk management. So what didn't call for their complete removal in 1990, but just from high-speed, high-volume roadways. And this is a video from around the time of the first memo showing the issue that was being reported. And hopefully you'll be able to hear the sound on this as well as I play it.
We'll call this in treatment the twisted and turned down treatment. The major problem with developing this system has been with cars vaulting and or rolling over. This occurs if the impacting vehicle rides up on the twisted section of the system and crosses the first backup post.
So it does seem pretty obvious to us today, at least, that this design would cause vaulting. Here is an old crash report that describes a rollover incident with a turn down. Hopefully you can see in the narrative what it says. It says that Unit 1 went off the right side of the roadway, striking the guardrail end, causing Unit 1 to roll over. Unit 1 continued on striking the right-of-way fence, sliding down the embankment, then it rotated and struck the inside guardrail post, eventually coming to rest on top of the guardrail, right side up. So this obviously did not exhibit those crash-worthy characteristics that we're looking for, redirecting or containing the vehicle, having an acceptable trajectory. This is part of an old crash report, which I don't have a copy of, so I can't tell exactly how fast this vehicle was traveling, but it does show the vehicle striking the end terminal at a relatively shallow angle. 4 years later, in September 1994, Federal Highway issued its second memo, providing some clarification and guidance on various obsolete hardware and what we at the time called poor practices. In this memo, we stated that new turn-down installations are no longer acceptable on high-speed, high-volume NHS routes. In addition, the state DOT must submit a plan and schedule to the Federal Highway Division offices for the replacement of all turndowns on the interstates. The existing turndowns on other NHS routes were to be replaced during times when roadway work comes in those areas. But the call was made 25 years ago now to systematically have a plan to replace them all on the interstates. And damaged turndowns are to be replaced with crashworthy terminals, not just in kind. So again, this memo was focused on the NHS specifically. So time goes on throughout the 90s and early 2000s, and then we come to November 2010 when we issued our next memo. In this memo, Federal Highway stated that it has been more than 15 years since the 1994 memo calling for turndowns to be removed from the NHS and saying that it's time for all remaining turndowns on the NHS to be upgraded as soon as practical. The memo goes on to say that turndowns may be used on the trailing end of a guardrail run to anchor the rail if it is outside the reverse direction clear zone and if it cannot be struck from the opposite direction. So again, we're continuing this theme of really applying to the approach end at this point. Just a note that if you pull up this memo, you need to go to the frequently asked questions in the back to find the guidance on the turndowns. The other ones were specific to turndowns, but you see as you scroll down, it'll say what guardrail must be replaced, and then it includes turndowns in here with a note to follow. And then we come to our fourth and most current memo that discusses turndowns, which we issued back in May of 2015. This memo states that obsolete, non-crashworthy end terminals still remain on our nation's highways, and that Federal Highway is trying to raise the awareness of these end terminals through a series of memos over the last 25 years. Agencies should increase their efforts to systematically upgrade pre-NCHRP 350 end terminals, which the turndowns are. They never were determined to be crashworthy under any criteria, and we want to upgrade those, particularly those on the NHS. So as you can see, while the emphasis is on the NHS, we did write that in such a way that we were now recommending that they be upgraded on all roadways. So you may be thinking, I understand what you're saying, but do we really have a problem with these? I don't recall seeing anything in the media about crashes involving these. Doesn't seem to be a big issue, or I would be aware of it. Maybe you would expect that we would hear more about this. Well, I do have a couple of examples just to show that these types of vaulting and rollover crashes still do occur. They're not in huge numbers. If you remember from that pie chart, they're not the number one most harmful event, but they do occur. This first one here is from 2016. As you can see in the description, it says that Unit 1 was traveling north on US 42. And these are from Ohio, by the way. Unit 1 traveled off the right side of the roadway, struck a guardrail, overturned, then struck a creek embankment. Even though the narrative didn't use the word guardrail end, this crash was coded as the vehicle striking the end of the guardrail. And this crash did result in a fatality. If you look at the photo on the left, it doesn't look like the embankment is all that high, but the rollover likely contributed to the severity of the crash. Posted speed was listed as 55 miles an hour. The crash form did not list an estimated speed, so yes, that could have been a factor. But even if they were going 65 miles an hour, that's still in the range of where our end terminals are tested at 62. And the sketch does show a relatively shallow impact angle, so it's probably in the realm of what we would expect as well. And yes, there may or may not have been impairment on the part of the driver. They may have been distracted, or whatever was going on with the driver. Still comes back to the principle that the end terminal should be less hazardous than what it's protecting. And it's tough to argue that a turn down end terminal is less hazardous due to the known issues with vaulting and rolling over. This is another crash report from actually the same year, 2016. Unit 1 was traveling northwest on County Road 167 when it lost control, ran off the left side of the roadway, struck a guardrail, struck an embankment, and overturned. Again, no mention of the end, but it was coded as a guardrail end on the crash report form. Again, this was a 55-mile-an-hour posted speed limit, but no speed was estimated on the crash form. Again, regardless of the circumstances of the driver, at the point they've left the roadway and we know they're going to get into a crash, the question is whether the guardrail and end terminal out there are going to help reduce the severity of the crash or not. And again, it's tough to find a way to say that the Type A will help. Quick point of note on either of these, they were vehicles that were approaching a curve. This one in particular, the officer, you could see on the right, noted that it was a downhill grade. So it was a combination of horizontal and vertical geometry that we often find vehicles, leaving the roadway. Yes, they do leave on tangent sections, but curves are definitely overrepresented. So what is our status here in Ohio with complying with that policy that all turn downs be removed from the NHS? Well, ODOT is currently in the process of removing all of the remaining Type A's from the state-maintained NHS routes. ODOT Central Office worked with the districts to identify how many we had out there, and then over the last couple of years have been getting projects sold to remove and replace them. And this does cover all Type A's on the NHS with one exception, that being the trailing ends on the outside of divided roadways if there's no likelihood of an opposite direction impact. So you may still see some on the NHS, but they should only be on trailing ends in these locations. So now that the state NHS removal plan is being implemented, the question then becomes, how many of these end terminals do we still have out on locally maintained NHS routes? And how can we get those removed? So ODOT is currently working to identify how many we have out on the local NHS, and we'll be soon working with the local agencies to get them removed. Both of these programs have been funded by ODOT using Federal Highway Safety Improvement Program funds, which is our federal safety funds. So now that's the NHS, which really only makes up a little over 5% of Ohio's roadway system. So then the question is, what about the remaining 95% of non-NHS routes? Well, ODOT currently has guidance in the L&D manual, the Location and Design Manual, in Section 600, regarding where the Type A end terminal may be used. And as you can see here, it would be on, all of these are non-NHS routes. The first criteria would be non-freeways or expressways with ADT of less than 4,000 vehicles per day. And it's currently listed as design year, although I'm not sure what the history of that, why design year was chosen. It probably should just be, with an ADT of 4,000. The second criteria is that they can be on non-NHS roadways outside the clear zone, and non-NHS roadways with a design speed less than 50 miles per hour. Again, I'm not sure why design speed was selected. I think we would rather see maybe operating speed. What are the actual speeds out there? From what I can tell, this policy was added to the manual after our first memo came out in 1990. So it's been around for a long time. Currently, our Ohio Division Office is in discussion with ODOT about potentially revising or possibly even removing this from the manual. Keeping this policy in the manual, maybe with some revisions, would still allow it on lower speed, lower volume non-NHS routes. And I think this is a risk management decision that ODOT and local agencies will need to make. However, I would probably still ask the question, will the Type A turn down ever really help to reduce the severity of a crash when somebody strikes it? So far, I haven't seen anything that really shows that it will. So Federal Highway would ask that agencies consider these items if you're still installing Type A turndowns on your local non-NHS roadways, or the state non-NHS roadways for that matter. It's pretty clear that the Type A is not crashworthy per our modern standards. It's basically only acting as an anchor for the downstream guardrail run, providing the tension that's needed to allow the guardrail to perform if it gets hit just beyond the end terminal. From what I can tell, the two main reasons they continue to be used are the cost and the belief that there isn't a problem with them. Yes, they do cost less than a crashworthy end terminal, probably less than half the cost. However, if safety is a top priority at our agencies, and it seems like just about everybody will tell you that safety is their top priority, if not one of their top priorities, then we maybe should be asking ourselves, when does spending that additional money become the appropriate thing to do? Again, we are knowingly placing a device out on our system that's not really going to reduce the severity of a crash. And while the numbers may not be readily apparent, these things do get hit, and they do contribute to the severity of the crash. Also, what we've been hearing is there's some recent concerns even with using the Type A's on the trailing ends. My understanding is that Texas has done some recent crash testing with a small car striking a turn down on the trailing end of a run of 31-inch guardrail, which is our current standard height for our standard guardrail design. And apparently there were performance issues with that test, which I don't have all the details, but apparently Texas is now reconsidering whether to even allow them on trailing ends on their roadways. One more video I have. The first part of the video is basically the same thing you just saw a little while ago, and it's followed by a crash test video for a crashworthy end terminal. And as you watch this video, I would just ask, which one of these end terminals would you rather hit if you left the roadway? Or would you rather that somebody you care about hit if they left the roadway? So I will go ahead and try to play this.
Has been with cars vaulting and or rolling over. This occurs if the impacting vehicle rides up on the twisted section of the system and crosses the first backup post.
So as you can see, that second part of the video was a newer MASH compliant crashworthy end terminal. And yes, the back end of that vehicle did raise up off the ground a fair amount, but compared to vaulting over, rolling over several times, landing behind the guardrail, this is obviously a much more preferred outcome for what we want when somebody, in a small car going 60+ miles an hour strikes the ends of these guardrail runs. So in summary, it is FHWA policy that all roadside hardware installed on the NHS shall be crashworthy. Again, regardless of who is paying for the installation, whether it's federal funds paying for it or just local city or county funds paying for it. We at Federal Highway strongly encourage that crashworthy hardware be used off the NHS as well. Again, our policy and jurisdiction for hardware only applies to the NHS. However, again, we know the vast majority of our system is non-NHS. People leave the roadway, whether it's NHS or not, for a variety of reasons. And our goal with the barrier, again, is to be less of a hazard than what that barrier is protecting. Quite simply, Type A's are not crashworthy, and they have been considered obsolete for some time now. And that is why they're being removed from the NHS routes in Ohio. ODOT's current policy, again, allows Type A's within the clear zone on certain non-NHS routes, typically the lower speed, lower volume routes. And again, our Ohio Division Office is having discussions with ODOT Central Office about potentially revising the policy that's been in there now for almost 30 years, I guess we're going on. I'm guessing that there might be a lot of local agencies that still install these or replace existing ones that get struck in kind with another Type A. I guess Federal Highway would just encourage you to consider upgrading them when they get struck or when you're putting a new one in, and upgrading them to a crashworthy device. And yes, I know there's thousands and thousands of these out there, and we don't have the resources to, go through quickly and do that. So maybe the approach is to start with the higher risk locations. Where do we think, there's more likelihood that people will run into them?
Ron, I'm going to interrupt real quick because we have a question that goes along with that thought there. It's from Mark Rahal, and he'd like to know, have there been tests to determine at what speed a vehicle needs to be traveling to vault on the Type A assembly? Some local agencies request these types still, and would be good to know this information to deter them from using them at certain speeds.
Good question. I'm not familiar with any tests to determine that. I think because at some point back in 1990, we basically said that these are obsolete and they're no good. So there was minimal testing done back at that time and in the 80s. What I would say is, obviously the higher the speed, the far more likely it's actually going to vault. So yes, maybe at 30, 35 miles an hour, they're not going to vault. But they will most likely roll over. They'll still not have, an acceptable containment type of thing we're looking for. Exactly what speed will actually get off the ground and vault into the air, I don't know. I can check to see if some of our headquarters folks have that. But then again, if you're talking something's, at 30, 35 miles an hour, then the question is, do you even need guardrail on such a low speed road? So it's a good question. I don't think we have an exact answer on what speed they would get off the ground. But even if they're struck at a low speed, they're really not going to react the way we want them to react.
Right. And whatever information you find, we can definitely send it out to everyone after the webinar. There's another question that's come in, and this one's from Erica Kensing. It says, what is FHWA's position regarding concrete barrier, tapered end sections on NHS routes?
I don't know if we have a specific position. I'd have to go through our guidance memos and that. I believe it's going to depend. My recollection of the roadside design guide in AASHTO, it all depends on the speed of the roadway and the distance from the roadway. I think if it's outside the clear zone, there's less of a concern, and if they're flared away from the travel lane path, there may be less of a concern. But this is another one that if you're going to leave the roadway at a certain speed, I mean, it's just if you look at it, it doesn't take much to realize that you're probably going to ramp up and vault over that. So again, I think that's similar to this. We don't want those in the clear zone on high-speed NHS routes. But I would have to look and see if we have an official position. I do remember there's some language again in the AASHTO guidance about those, but I think it was contained to smaller or lower speed, lower volume facilities.
Thank you, Ron. And just as a quick reminder to anybody who or I guess just as information, anyone who joined us after we started the webinar, we are taking questions through the chat pod today. So if you don't see the conversation panel on the bottom left-hand side of your screen, please look for the circle with a thought bubble in it and click that in order to view the conversation panel and then to type your question in, and I'll read those off to Ron. Thanks.
Okay. I'm getting close to the end here. Just kind of follow up on that thought with, we do encourage they be replaced on all routes, but we acknowledge that it's, with thousands and thousands of them out there, at least in Ohio, that it might be best to start with your higher risk locations. And where are our higher risk locations? Well, again, it's clear to us, a federal highway, that curves are overrepresented in terms of roadway departure crashes. If you add up all the centerline mileage of all of our roadways, the amount of the total length that is attributed to curves is a very small percentage. However, we see a much larger percentage of vehicles leave the roadway at curves, particularly when there's a vertical geometric component as well coming down a hill. So this is an example of one that is actually relatively close to us here in Columbus that I drive by occasionally coming down a hill either direction. The culvert here is right in the horizontal curve and obviously at the low point of the roadway. So it doesn't take much, wouldn't take much to veer off the right side of this roadway in either direction, but notably in this direction, and hit the end of that guardrail, and then you're almost certainly going to be launched off into the property that's there. So eventually, so I think our suggestion would be to see where your higher risk curves are on your system. I assume that the local agencies typically know where their problem areas are, and the state does as well. And yes, we maybe can't replace all of these all at once, but as we go through time, at least if we commit to getting the higher risk ones maybe replaced and upgraded, then we'll have a safer roadside.
So I've got some more questions for you, Ron. They came pouring in. The next one is from Daniel Boltz in Belmont County. He wants to know, do the crash tests measure forces imparted to the driver based on the rate of deceleration? While the Type E MASH compliant ends stop the vehicle from a rollover, it seems a much higher load would be imparted to the driver. Think Dale Earnhardt at Daytona or the NFL CTE or concussions.
Yes, I believe the crash tests do measure those forces. That's those occupant velocities and those ride down accelerations. And it does seem like that car that was just coming to a stop, hitting that MASH compliant one, going from 60 to 0 in a matter of a second or two, would seem to be higher. However, that end terminal is designed to absorb that energy as the vehicle is striking it. So yes, some of the energy is imparted to the vehicle and the compartment, but the majority of it is absorbed by the terminal itself. So so just what we've seen is those are clearly safer. At 62 miles an hour, yes, the Dale Earnhardt at Daytona was a different situation, going 200 miles an hour. So in the system back then, I know they've changed their barrier system on their racetracks since then. The system back then didn't have the current features it does. So yes, when you vault and roll over, you saw how many times that small car could roll over, and then oftentimes we may be launching vehicles into the hazard that the guardrail is trying to protect. That's the other thing. If you just roll, on a maybe a hill or something, maybe you could survive. But if you're, we may be launching them into a bridge pier or something else that clearly would be more hazardous. So.
Okay, we've got another question. This one's from John Durkos. He said, would you recommend the length of need be evaluated before simply replacing a turned down end?
I would say yes, we would. I mean, unless one was just hit recently and you know that the length of need was looked at, fairly recently, and you're confident that we have enough guardrail out there, then yes, anytime we're doing anything to guardrail, we should be taking a look. Do we have enough out there? Do we have too much out there? Again, these systems are strong, and they will damage vehicles and cause energy to be imparted. So we only want to have as much out there as we need to protect the hazard. So oftentimes, yeah, you may see locations that don't have enough, but I've driven by and it's like, I'm not sure why that guardrail is even there. So considering what's behind it. So yes, absolutely. We want to, if we're upgrading an end terminal or a guardrail run, the best thing to do would be make sure we have the right amount out there.
Okay, last question so far. There might be a few more that come in. This one's from Joseph Clark. There are many areas with type A's where existing grading and right-of-way are not correct for type E installation. Is a type E with out-of-spec grading preferable to a type A in most circumstances?
That's an interesting question. I would say, the obvious preferred would be to have a crash-worthy end terminal that you can get the appropriate grading in, because these end terminals were designed and tested under certain conditions, and that includes the grading that is around them. So, I mean, I don't think Federal Highway has an official position on that. I mean, me personally, I would rather hit something that's crashworthy, that we feel that's in there well. We took the care to grade around it and make sure it's installed per manufacturer specs, and it gives us the best chance of performing well. Okay, if there's some reason we have to make it fit and we have to do something to make it work, I would rather hit a end terminal that's as crashworthy as close to that crashworthiness as possible. And the type A, there's really no component of that appears would be helpful to you if you were to hit it. Again, it's only providing the tension to that downstream guardrail if you hit the guardrail downstream. So I guess I've answered your question, although officially, we want to do everything we can at each location to get in crashworthy terminals as they're intended. But I do understand out in the field, you do have constraints, and you have to make things fit as best you can. But I would rather hit one that at least is a crashworthy terminal, even if it doesn't have, all of the, elements. Maybe the grading is slightly off. I'd rather hit that than a type A, me personally. So.
One more question, Ron. It came in right as I was reading the other one. This one's from the Butler County Engineer's Office. Slide 30 is similar to what we have on our local county roads. What kind of end assemblies would you use on the driveways that are closer to the structure that won't create a sight distance issue?
Yeah, slide 30, I assume that's the current slide up there where we have this just a culvert here with a short run of rail. And I agree, we see these all over. My first thing here is I'm looking at this photo, and I'm guessing the right-of-way line is at somewhere where the utility poles are. Is there any way we can extend the culvert, do some regrading, and not even have to have guardrail in there? It's a risk management type of decision. If we can extend that, maybe get some grading in there, see if we can push that out. Maybe we don't even need guardrail. Yes, maybe that's not possible, and I agree if there's an intersection or there are other issues. In engineering, we got to use our judgment, do the best we can to fit it in there. So, first scenario would be, again, can we redesign it so that we don't have a barrier? Can we redesign the hazard? And then if we can't, then we have to try to get in the best situation that's possible to make it fit. So I don't know if there's nothing, I don't know there's no low height guardrail that we use so that you could see over it. Again, these things are designed and tested in a certain way, again, to account for that worst practical condition for either a small car or a pickup truck. So not a great answer, but I know when you're stuck in a tight spot with intersections and bridges and stuff, sometimes there isn't a perfect answer. You just have to make the rail fit as best you can. But again, the Type A really doesn't help you at all. It's, you know, other than providing the tension for downstream, it really doesn't help you if you were to strike it.
Well, there's no other questions so far, so whoop, they popped one more in there. Sorry. We do still have a few minutes, so I'm going to read this one. It's also from the Butler County Engineer's Office. If we have a long stretch of Type 5 guardrail with Type A end assemblies, can you just replace the Type A end assemblies with a B or E and leave the Type 5 guardrail varying heights?
You can, and this may be a better question for ODOT. I know the current guardrail standard is the MGS, the Midwest Guardrail System, which is higher than the old Type 5 guardrail. You know, I believe you can replace those with a crashworthy end terminal that attaches to it. Again, I'd have to get into the ODOT standards and look at that, but the intent here is not to say that if you go out there and you have all old Type 5 guardrail, you really should replace it all. I mean, yes, if we all had all the money, you know, possible, we could go out and replace everything and bring everything up to standard. But we acknowledge that, you know, with limited resources, it's best to get the, you know, the higher risk locations addressed. And a Type A end terminal would be what we consider, you know, higher risk than just having a long run of Type 5 guardrail out there. It's been out there a long time. Yes, it may not perform as we want with some of the newer, taller vehicles, but really that Type A, again, come back to it, there's really no part of that that's going to help you. So, so from our perspective, yes, if you can get a crashworthy end terminal in there to work with the Type 5, then that would be a good thing.
Well, I want to thank you so much, Ron, for all of your time today in presenting the webinar and also the time you've put into preparing it, because the PowerPoint is going to be an excellent resource for everyone moving forward. We only have a few minutes left, so any further questions that come in, I'll just pass those along to Ron so he can respond to them directly, or he has provided you his contact information on the screen. You're very daring, Ron, putting all that information out there. Your phone might be ringing off the hook.
That's okay.
So, but thank you so much for doing this webinar for us today, because this is an incredibly important topic. I know myself, I drive by Type A turn down ends on my commute daily, in the morning and in the afternoon. So, you know, it's definitely a pervasive issue here in Ohio that we want to take a look at. And like Ron said, risk management is definitely key in beginning to address this. So thanks so much, everyone, for joining us. And Ron, do you think it would be fair with the questions that were put into the chat pod for maybe a week for you to put some responses together and research, or do you need a little bit longer?
Sure, yes, I could do that over the next week or so. Yeah.
That'd be great. And what I'll do today is send out a link to the recording, hopefully, and the PDF copy of the PowerPoint, and then as soon as Ron has those responses researched for you and we've got that together, we'll send out a follow-up email to everybody. So in the meantime, Ron's contact information is on the screen. Please feel free to reach out to him, and thanks very much for being a part of the webinar today. We appreciate it.
Thank you.
Thanks.